Friends, in the today's session, we're going to see regarding the points regarding the fuse, MCB and isolator switches. Whenever we are constructing the solar power plant, actually, in that cases in the electrical circuit, we require some fuses in the combiner boxes. We require the MCBs, that is a miniature circuit breaker, and the isolator switches. One by one, we will see in the particular lecture actually how the fuse, MCB and isolator switch means and how we are using this in the solar power plant. Basically, when we talk about the fuse, about the basic, it is a basic electrical device actually. In the fuse actually, the amperage capacity of individual fuse is varying from 50 ampere up to 32 ampere. Most of the cases when we are combining the two strings in the solar panels actually, or the solar power plant, when we are giving the strings output to the individual NPPT, in the particular cases we need to combine the strings in the parallel combination. So in the particular cases we require the usage of the fuse over here. So basically, whenever the any wire, that is a live wire or a neutral wire, which is coming from the particular string, first it has been fed to the particular fuse over here. This is a live wire from the string number 1, which is coming from the number of solar panel which are connected in the series combination. And second thing, which is a neutral wire, we want to send to the particular fuse over here. So whenever we are connecting this particular solar strings to the inverter, we need to give the particular live and neutral wire connection to the fuses over here. In this particular box, when we open this box actually, such kind of fuse has been located over here. In this particular fuse, when we see such kind of the metallic strip or the wires has been located over here. It is a zinc, copper and the number of alloys. By constructing like this, this particular wire has been made. So let's say the particular rated ampere of a fuse is 15 ampere. If a current from the particular string goes beyond this 15 ampere, the metal inside this fuse is getting melting over here due to the high temperature increase because of the increase in the current value in the particular fuse. So that is why whenever, like let us say the string number 1 is having the current of 8.75 ampere, and this particular 8.75 ampere, if we are feeding to particular fuse over here, we have to select the double amount of the fuse over here. It means that whatever the string current is flowing in a circuit, 8.75 multiplied by 2, on an average we will get 16 ampere or 15 ampere of the particular fuse we need to be used in the circuit over here. And from this, on the output side, we can take a output from the live wire and we can take the output of the neutral wire, and subsequently we can give this particular output to the either the MCP which we are connecting for breaker protection or the particular SPD whosoever we are connecting in the parallel combination. So ultimately the use of fuse in the solar power plant is nothing but whenever we are giving the output of the strings through these particular fuses, it is protecting from the particular circuit from overcurrent protection. Up to the 15 ampere if we are selecting, beyond 15 ampere the fuse is getting melted over here. Once the fuse has been getting melt in the particular circuit, we have to replace the particular fuse or purchase a new fuse and just insert into this particular fuse holder which has been given over here. When we see the AC fuses, which we have seen the number of the utility companies were using such kind of the old fuses actually. In these cases also, when we open this front upper part over here, we found there is a small strip has been located. Whenever any excess current is flowing through this strip, as per the selected specification, it is getting melted over here, and due to which our circuit is getting protected from the DC side to the AC side in the solar system. Basically, whenever we need to choose any kind of a fuse for the solar power plant, we require to check it for first the voltage range up to the which maximum voltage the particular fuse is tolerable. Most of the cases the DC fuse is tolerable voltage up to 1000 volt DC. And second important thing is the ampere range capacity, what ampere current it is tolerable over here. It depends upon the which string current we are giving over here. If the two number of the strings we are combining in the parallel way, and if their current goes beyond 20 ampere, we have to select the fuse which carries up to 40 ampere of the current from the particular strings over here. So whatever amount of string current we are giving, double the current that we have to select for particular fuse selection. Again, in the case of the photovoltaic solar panel installation, the fuse class is separate, that is a photovoltaic fuse class. We have to select in the selection of the fuses in a combiner boxes. Generally, the use of the fuse is there in a combiner box whenever we want to connect the number of the series in the parallel combination, or to take an output of the strings in the particular parallel combination and to give it the output into the inverter. The second thing we're going to discuss is the MCB. MCB is called as the miniature circuit breaker. Miniature circuit breaker, it is nothing but it is a kind of a circuit breaker actually. Whenever any kind of the excess current is flowing inside the circuit, due to which the two metallic strips has been located actually on the upper and the lower side, due to the increase in the temperature, due to the high increase in the current actually, it breaks the circuit and circuit becomes the open circuit voltage, or the particular open circuit it becomes, so that the current from the DC it will not go towards the AC side actually, thus it is protecting our circuit. Most of the cases, the old kind of technology, we are saying the fuses we are using in the combiner boxes. Nowadays this fuse we can replace with the miniature circuit breaker. This is the MCB. Function of the fuse actually and function of the MCB, which is almost remain same. We are selecting the fuse based on the ampere range capacity. Simultaneously MCB we are selecting also on the ampere range handling capacity over here. Only thing is what, once the fuse has been melted, we have to replace the fuse. But once the current goes beyond the acceptable range of this, some amount of a time this MCB is getting tripped over here, and due to the tripping of this particular MCB inside it, we can just manually make a switch on over here, so that we don't want to replace this particular MCB each time whenever the tripping is happening in the particular circuit over here. Basically, it can be the reclose without any hand operated restoration. MCB is used as an option to the fuse switch in the most of the circuit. Unlike the fuses, MCB doesn't have to replace every time whenever we purchase over this. Whenever it is tripping actually, we just manually go and just put the MCB back on the operation, so that again the electricity will go to start flow in the particular circuit actually. Basically, whenever we are selecting the MCB, nowadays in the market there are number of MCBs were available, like a single pole MCB. In a single pole MCB, we can give only the live wire over here. Only the live wire we can give in the single pole MCB over here. But whenever we need to connect the live wire plus neutral wire, that time we have to choose the two pole MCB over here. So here one time we can connect the live wire of the string number 1 or a solar panel, again the neutral wire of the solar panel over here. So whenever any kind of the excess current is flowing through this MCB, restless to the particular rating capacity, let's say it is a 16 ampere rated capacity. If it is goes beyond 16 ampere, let's say the 20 ampere, this circuit is tripping over here and this switch is getting off over here. Again, after some time we need to make this switch on for the working of this particular miniature circuit breaker. And from the output side, we can take a live wire and we can connect to the parallel in the way to the SPD, and again to the terminal boxes we can give the connections from this MCB over here. Most of the cases, whenever we want to do the maintenance in the solar sector or a solar power plant, we just shut off this particular MCB and then we can go for the maintenance of the solar panel or the solar inverter. Simultaneously, for the three-phase connection, we can use the three-pole MCB over here. So this one live wire number 1, which is R, second is a Y, and this is a B over here. The three live wire we can connect to this particular MCB, and separately on the terminal box we can connect the neutral supply over here. Again, from the output side actually we can take out this particular three live wire connection, and subsequently we can give the parallel connection to the SPD. Rather, we can give to the terminal box or the phase terminal box also we can give this connection in the DCDB or the combiner box. Whenever we are connecting the three live wires actually, that is R, Y and B, and the neutral wire also, it becomes the 4-pole MCB actually. Most of the cases 4-pole MCB for three-phase connection, it has been more recommended for the safety operation of the circuit actually. Again, from the output side we can take the three live wire L1, L2, L3, or you can say the R, Y and B, and from here we can take the neutral wire supply over here. Likewise, the miniature circuit breaker usage is very important in the solar power plant actually. Whenever we want to protect the circuit from the overcurrent protection, Basically the MCB is used for the overcurrent protection most of the cases, and from the over voltage protection we require the separate surge protection device called as the SPD, we can say over here. Whenever we want to select the MCB, there are two kinds of MCBs available in the solar market actually. One is the DC MCB we required. Again we require the AC MCB. DC MCB is used in the DCDB, we can say, that is a DC distribution board, and this is used in the ACDB, or we can say it is a AC distribution board. Some of the other cases also say the combiner box over here, that is a DC combiner box. In that also we can use this MCB. Simultaneously we can replace the fuse with this particular MCB, then also it is been more okay over here. Whenever we are selecting the MCB from the market, we have to focus on this particular amperage range capacity of the MCB. If a string current is coming from the particular solar panel, let's say the 30 ampere, we have to choose the standard rating of this MCB as almost 60 ampere, but then market actually it is been available of the 63 ampere standard rating, so we have to select this particular MCB for the solar project. In the DC MCB we have to check the maximum rated voltage of the particular MCB over here. In the most of the DC MCBs it is up to 1200 volt DC. Again from the DC side we have to check whether it is a single pole we are connecting, rather it is a dual pole we are connecting with a live plus neutral wire connection. On the AC side, when we choose the particular MCB on the AC side, again we have to focus on this particular ampere rating, whosoever current is coming from the inverter actually, because as we know we are attaching the inverter in the solar power system. If the current is coming from inverter up, let's say up to the 15 ampere, we have to choose the MCB on the AC side up to 30 ampere, almost double the size of the current which is coming from the output side of the inverter. Again, what is the rated insulation voltage? We have to check it that also, rather it is a single phase, rather it is a three phase. If it is a single phase, we can go for single pole for the live connection, or we can go for dual connection for the live plus neutral. For the three phase, we can go for the three pole MCB as we have seen in the earlier slide, or the four pole MCB for the better safety of the system actually. Then there is a next parameter comes is the isolator RCCB over here, that is we call it as a residual current circuit breaker. So basically residual current circuit breaker or the RCD, it is called as the residual current which is flowing, or the earthing current which is flowing in the circuit actually. If any kind of the short circuit will be happened, or any kind of the current will be there in the outer body of the any kind of instrument, the main function of the RCCB is that it just sense the particular milliampere change in the particular circuit, and according to that take a action and shut off the particular circuit at the particular cases. So that is why we are using the RCCB on the AC side. On the next side of the MCB, we are connecting the MCB over here. We give the series connection to the particular RCCB which is connected on the right side actually. RCCB we are using on the more safer side. It is protect the circuit from the overcurrent protection, and also protect the circuit from the earthing fault which are occurring over here. Any kind of the reverse current which is flowing from the ground or the earthing, any kind of a short circuit will be there, or the current will be there in the outer body of the any kind of a instrument, let's say the inverter, let's say the TV, let's say the refrigerator. In that cases any kind of the milliampere change will be there. The RCCB sense this particular milliampere change, and according to that it will shut off the particular circuit in the particular moment over here. And that is why we are using the RCCB on the more safer side in the solar power plant actually. Basically the RCCB is basically an electrical wiring that trips or disconnect when the imbalance or mismatch in the electrical current is being detected. This mismatch has been detected in terms of the milliampere, very small milliampere to be sensing over here. So thus any kind of the earthing fault will be occurring in the some span of a time. In a short span the RCCB senses and shut off the circuit, so that any kind of the hazard it might come in the future cases, that should be avoided by the usage of the RCCB over here. RCCB will look like this. If we are going for the single phase connection, then use the double pole RCCB for live and neutral connection, and this has been connected in the series combination with the MCB that we are using, that is a AC MCB that we are using over here. That is, one is a live wire, another is a neutral wire which is coming from the MCB which we are connecting in the particular AC side. For the three phase connection, we can go for the 4 pole type of the RCCB over here. That is 3 are for the RYB connection and last is for the neutral connection over here. So likewise, when we purchase this RCCB, here it has been written that the milliampere sensing of the particular RCCB. So whenever we are purchasing any kind of the RCCB, we just check what is the milliampere sensitivity the particular residual current circuit breaker is having over here. Basically, when we purchase the RCCB from the market for the solar power plant, we need to check what is the current carrying ability or the current rating it is having. Whosoever MCB is having the current rating, let's say the 40 ampere, the same should be we have to select for the RCCB, that is the 40 ampere. Again, the current sensitivity we have to check how the quickly it will respond and which type of the pole actually we required in the particular circuit. Then we're going to select what do you mean by the isolators. Isolator switches are nothing but the isolator is one kind of a switch actually which isolates the part of a circuit system when it is required. Electrical isolator are the separate part of the system that is created for the safe maintenance. Isolator are generally used at the end of the breaker to repair or the replace. As we know, we are using the MCB in the circuit, we are using the fuses in the circuit, also we require to use the isolator in the circuit. Whenever we want to do the maintenance on the DC side where we are connecting the number of the solar panel over here or the solar array over here, so that time we require the isolator switch. We simply shut off this particular isolator switch so that we can do the maintenance on the DC side, also maintenance on the AC side over here. Isolator switches are look like this. For the dual pole isolator switches, it will look like this. This is live wire plus neutral. Also there is a 4 pole isolator switches. We can go for lesser current carrying ability, let's say up to the 63 current carrying ability of the 3-phase connection. But whenever we are going to deal with the higher current carrying ability of the 3-phase connection for the residential scale, commercial scale or industrial scale, that time it handles the current up to 200 ampere, handles the current up to the 500 ampere, more than 100 ampere it will say actually. More than 100 ampere when we require, that time we are using these rotary type of the isolator switches. Whenever the current is coming or whenever the supply is coming from the utility grid, that is the R phase, Y phase, B phase, and this is a neutral type coming, so it is been given to the isolator switches and again it is been routed to the outgoing supply to the metering panel over here, so that just rotating the switches on the off side we can do a maintenance on the particular metering room over here. That is why the isolator switches are more important in a circuit. Basically, in the isolator switches specification on the DC side, we choose the particular current carrying ability, we choose the voltage in the DC and number of poles over here. And the AC side actually also we are selecting the what ampere capacity it will be satisfactory, whether it is a 3-pole if we are going, it will require up to the 63 ampere rating of the particular isolator switches. Like that, the particular single phase voltage and the 3-phase voltage, we can go for the dual pole and 3 and 4 pole circuit over here. Just for the safety precaution or for doing a maintenance purposes, we were using the isolator switches in the solar power plant on the DC and AC